Okay, it's 4:15, so I guess I'm going to get started. I'm Jackie Cohen, and I'm talking, as you can see, about Python for curious people who like natural language a lot. I'll come back to the reason for that title in a bit. As for who I am, I'm currently a software developer at the University of Michigan. I have a background in linguistics. That's what I studied in college. If you want to get the slides, there are some links and stuff that I'm not going to be going into detail about. They're at that link, or you can get them later. So today I'm going to be first defining terms and giving some background and explaining my excitement a little bit. Pretty much this talk is about how natural language is awesome and language is really, really cool. And as Python programmers, even if you're just starting out in Python, there are a lot of really neat avenues into which you can dive and explore and build stuff. I'm going to ask some questions I think are relevant to the intersection of natural language and programming, especially Python programming, and provide some high-level beginnings to answers of those questions that people can start diving into. And then talk a little bit about why I think those are good questions to be asking and why this stuff matters. So first, language. I'm drawing a bunch of really broad categories in this talk because it's supposed to be very high level. So by natural language, I mean the stuff that humans use to communicate usually. So in English is natural language, French is natural language, but also the stuff that you talk about with the stuff that you say to a friend or family member or whomever. Say you have a social group that tends to talk in multiple languages, like in English and in French, or in Spanish and Mandarin Chinese, whatever. That's still all natural language. These things that we call, say, English and French are really political boundaries more than like absolute sets. And then by formal language, I would mean how humans communicate with computers for the purposes of this talk. So Python is a formal language, as is SQL and Java. Both of these things are really broad areas of study that a lot more distinctions can be drawn within them, but that's not the point today. And so we're at a Python conference, right? And Python, I think in particular, is awesome for this purpose, and also just awesome. So there are some reasons that I think the set of tools in Python is particularly good for natural language exploration and diving into like why natural language is really cool. Some of those reasons are that it's fairly easy to write very clear code in Python. Some code in Python can look a lot like pseudocode. It can look a lot like English. And so that makes it, that and other things make it a good teaching language. Teaching Python is also something I'm really interested in. And looking at the intersection between natural language and Python and doing linguistics type research in Python is, I think, a really interesting tool for teaching Python. Python has interesting similarities to the way you structure sentences, for example, in English in particular, and very interesting differences, so it's easy to point out formality. Some of my introductory students struggle with for loops for a while until it clicks, and I find the syntax of writing them in Python really helps actually explain what they're doing. But I also think Python is really awesome for natural language exploration because of its flexibility. And I mean that in several senses, both because you can do various types of programming in it. You can make your programming more sort of functionally oriented. You can use object-oriented programming, but you don't have to understand a certain set of things strictly in order to program in Python. And there are a lot of people, not just Python programmers, who I run into who tend to say just, I love language. Like I mentioned, I have a background in linguistics. That's what I studied in college. But it's a huge swath of people who talk about how they love language, either because they identify as word people or any large set of reasons. And so that's another reason I think it's really powerful to be able to use Python to explore that and answer questions about language. Language touches everything we do in some way or other. It's also a major reason that I'm a programmer. I was talking to a friend now many years ago, who was a computer science major, and he was talking to me about his operating systems project, and started using the word syntax and semantics, and I knew what those meant despite having never programmed on a computer, and the next semester I took my first programming class. And I've noticed as I've continued to move through the programming computer science communities as a developer that there's a big overlap in those communities and overlap in lots of social science and computational communities. But still there's not a lot of sort of cross-disciplinary conversation. And so this talk is really aimed at celebrating that intersection. I think there's a lot of really great collaboration and interesting question answers and just neat stuff to be gotten out of celebrating the intersection between exploring language and asking interesting social science questions and understanding programming tools and the tools that are available, especially in Python. There are lots of options. So so the intersection I'm talking about is sort of weaving together these two ideas at far sides of the spectrum. One, it's like this linguistics research thing sounds neat. I really like language. I think it's really cool. What does that really mean? What can I do that hasn't already been answered? How can I start? This is such a huge field. And where I was coming from about 7 years ago, this building stuff sounds neat. I want to make something understanding a lot of theoretical concepts about linguistics, but I don't know how to make it. I think I have to learn so much in order to get there, and I don't think that's true. So can we weave these things together well? I think the answer is almost always yes, especially what involves programming that's easily accessible. But I'm going to go a little deeper and talk about some some ways to access natural language exploration using Python. So I would say we have some questions to ask and answer in order to pursue this. Like, can we weave these two things together well? First of all, what's linguistics? Then what choices must we make if we're going to pursue these kinds of questions? Where should we start? What are the best jumping off points? What can we do right away that we can then dive into deeper? And why does this stuff matter? So firstly, what's linguistics? This is a question that I get a lot. I don't know if there are other self-described linguists in the room, but often my experience is that you get questions like, do you speak a lot of languages? My answer is no, but it is possible. Like, studying linguistics may make it easier to learn languages, but it's really about studying parallel overlapping systems. It's about the system of natural language, as I defined it in that first slide. Another thing I think is important to note when you think about what is linguistics, which is a huge thing, every representation of communication is a thing that can be analyzed separately. So a writing system is not just another way of representing speaking, although it also is. It's really complicated. Like I was mentioning before, all of these things I'm touching upon are really deep topics in and of themselves, and they're worthy of a lot more research and question. But one of the things that I want to get across in the talk is that even though all of these things are individually so interesting and complex, you can still answer really interesting questions without having done years of background reading or having tons of industry experience. So another thing that is important when I think about what is linguistics is that in linguistics, it's important to think about how complex structures are generated from simple rules. This is something that programmers are frequently very familiar with, of course, but it's also something I think we're all familiar with in natural language. If you have a poem that you're analyzing in a complex way, it's not because the sentences are necessarily complex, but that things combine to create complex meaning. And there are lots of other examples of that. And then finally, I think it's important to note that there are tons of subfields in linguistics, really tons. I'm going to focus on 3 in particular here, which leads us into, okay, what choices must we make if we want to do this kind of analysis? So you want to choose between what aspects of natural language you want to look at, or what particular aspect. What is the question that you want to answer? The three subfields of linguistics that I'm going to talk about are semantics, phonetics, and syntax. But there's also phonology, historical linguistics, and many, many intersections with like anthropology and psychology and numerous other social factors and measurements and just all kinds of things. And then there's also the choice of what libraries and concepts in Python you want to use. So one of the things that I think is really interesting and worth exclaiming about in this intersection of disciplines is that you can come at it from either side and be successful and make something interesting. So if you want to learn about compression algorithms in Python and use natural language exploration to do that, that's a possibility, and there's a lot of work to be done there. If you want to answer interesting questions about the meanings in words, then you can do that using maybe like a certain tool in Python. So there are lots of different avenues from which to come at this, and I think that makes it a good entryway into programming and also a good entryway into just exploration and fun. So this is a little bit more detailed description of the three subfields I'm going to provide jumping off points for today. Phonetics has to do with looking at the discrete units of language, how we produce them and consume them and put them together. This is a broader definition of phonetics, and I think most people would usually use, and that's because I've heard some people refer to discrete units of signed languages as phonemes as well. A phoneme is an individual sound unit. For the purposes of this talk, I'm really mostly going to be talking about sound, but linguistic analysis in signed languages and others like representation systems is also really cool, and a really new field relatively. But for now it's just sound mostly, but that's why the broad definition. Lexical semantics has to do with what words mean to us and how they relate to other words in one language system or among many, like the connotations and the way we understand what words mean. And syntax is something that programmers are also, of course, familiar with. How we parse language, how pieces of together, grammaticality in natural language. We don't get syntax errors, but actually we kind of do. But again, there are lots of other cool things. So if you're going to start in like a really high-level exploration of natural language, I want to find stuff out about human language, this is where I would suggest starting, the Natural Language Toolkit. It's not the only tool. It's not the best for everything, but it's a great starting point. And it's proved really useful to me in introductory Python classes and also just general stuff that I want to do. So I'm not going to be doing a lot of code here, but this is just like, it comes with a bunch of data sets and corpora. If you go to that website, you can download all the data that goes along with it. There's a bunch of stuff. So just like a brief mention of how useful NLTK is for this kind of thing, like looking at this intersection of natural language and programming at a high level. It's open source, so you can do all the things that that entails. There are issues open that you can fix, but it also means that if you're interested in sort of the programming side of this and diving into Python and using natural language as a space in which to explore Python, one class I took built up a lot of the things that NLTK had built in slightly different ways, and that was a really useful learning tool that I've continued to use when I write other parsers and stuff like that. It also provides lots of code samples, things you can easily alter, and although this isn't always the best plan, ways that like you can use complicated tools and algorithms without thoroughly understanding them, so you can answer interesting questions. So if you're interested in the linguistics side of it and answering social science questions, I think that's a really powerful tool, especially because there are a lot of good explanations. So you may not understand a specific machine learning algorithm, but you can understand what the result is, and that's powerful. And so all this stuff with the caps at the bottom of my slide, I think this is really worth emphasizing. Whatever level you want to dive into in exploration of natural language and programming and using computation and social sciences more generally is awesome and okay. And that's important in that if you want to just use the tools provided in NLTK and other programming libraries and think about what questions to ask, that's not only obviously hugely valid, but really there's a lot of research that has not been done or touched on much. And there's a lot to be done there, but also there's a lot to be done in terms of making things more efficient and thinking about the programming side. There are just a lot of exciting doorways that you can enter here. So in terms of jumping off points from these three subfields in linguistics, one example in syntax has to do with parts of speech. Parts of speech taggers are pretty awesome. For those who may not be aware, what I mean by part of speech is like whether something is a noun or an adverb or a determiner, like the. And there are different algorithms that are built into part of speech taggers, and there's more than one included in NLTK. There's a default one that's used. So this is a little bit of code here, just a sentence. NLTK has a word tokenized method, so you don't have to deal with implementing weird punctuation stuff or contractions, stuff like that. It's very good at guessing, basically. So you get this tokenized snippet that separates a word into word tokens as humans understand them, which is really interesting if you're teaching. I have found it really interesting teaching for introductory programming, especially in Python, because it looks so much like English. It takes a minute to think about like how you define a word. The way that NLTK word tokenized defines a word is maybe different than you first think of telling the computer to define a word, which for most of my students is like the spaces, and then you get more complicated. So there's that, and then NLTK has this POS tag method, which uses its default part of speech tagger on a list of tokens to produce something like this. So it turns the list of strings into a list of tuples whose first element is the word, the string, and whose second element is the abbreviation that stands for the part of speech it thinks it is. So this is a really interesting jumping off point for various computational questions having to do with language, because you can do stuff like easily find out how many words in a list are singular nouns, but also because you can tell from human knowledge or other testing data, et cetera, et cetera, et cetera, that some of these are not going to be right. Just in this sentence, like brown, in this case, is not a singular noun. And we know that as humans reading an English sentence, probably, but the tagger doesn't. So another interesting thing about syntax is thinking about grammaticality, which is just generally interesting. I just think it's really cool. I have a bunch of friends who will sometimes, for example, post on Facebook, does anyone find this sentence grammatical or ungrammatical? And there's disagreement, even though, say we went to college together or something, we come from different backgrounds, we now live in different places, and our dialects are going to be different depending on what's affected us in our lives. This is the wrong sentence because I was apparently really tired when I wrote this slide, but the real sentence is colorless green ideas sleep furiously, and it was proposed in a paper by Noam Chomsky in the 50s that like this is a grammatical sentence. We don't read it and think like it sounds wrong, but it doesn't mean anything. This one may not mean anything either. But so that's not ungrammatical syntactically. This sentence, I go to work on the bus all the time anymore, is something that I think is probably grammatical to some people and ungrammatical to others. It's grammatical for me, using the positive anymore as like now I go to work on the bus all the time, but a lot of people don't use the positive anymore in my experience. And so if it's not grammatical to you, if it sounds wrong, there is no right or wrong answer here, which is one of the interesting things about syntax in language. Like a lot of the rules on the tin are not real strict rules, but sometimes they kind of are. Jump, trash, sink, phone, hotel, because I really doubt that's grammatical to anyone in this room. It doesn't make any sense to me. And it's surprisingly hard to come up with a sentence that you really don't think is going to make sense. At least I thought it was. But this is a syntax problem. These words, like the parts of speech, just don't make sense. So it's like, for most people, which is kind of how you have to judge things in natural language, like enough people will have a metaphorical syntax error for this sentence that it's not really grammatical. And so an interesting subfield of linguistics, one might call it, is thinking about reasons why things are ungrammatical. It's hard to like come up with the set of rules that make that true, but it's interesting to try and figure out how humans' brains think, like parse these kinds of things, the way a compiler parses Python. And so you can use this stuff in the part of speech taggers to try and pull that apart and ask questions about why that might be. So that's one sort of jumping off point. In terms of phonetics, dealing with sound in Python is not something I have a lot of experience with, but it's something that I think has a lot of potential to be cool. Like I said, spoken and signed language is made up of individual discrete units. There exists the International Phonetic Alphabet, which is a bunch of symbols that describe all the different sounds that like humans can make that are included in various languages, like ah or ul. Those are phonemes. But this brings up a whole host of issues when you come to computation. One of them is text encodings for all these different weird symbols that aren't ASCII. And many of us in the room are probably familiar with problems of text encodings. These are things that can lead to interesting linguistic analysis, but if it's not what I would recommend for a first like dive into language analysis, because what I'm pointing to in this talk is like, say you think language is really cool and you want to use Python to play with it. Just right now, character encodings is not the way I would go. But there are some cool corpora and resources that make it possible to play with sound stuff and find answers to questions fast. One example is the Carnegie Mellon University Pronunciation Dictionary. Excuse me. So you can get to it at that link. Another is Prot is a set of software. You can do find spectral analyses of sound over time. I just found out an hour ago that there's a Python interface to Prot that I haven't played with, so that might be really cool. It might not, I don't know. But I'd be curious if any of you have worked with it to talk about it. But I think basically in phonetics there are a bunch of really neat questions to be asked about like syllables and stress. How do you find rhymes? What is the best way? How do you measure prosody and what does it say in different contexts? So if you don't know what prosody is, like if I speak like this, it's a different prosody than what I'm speaking like right now. And then there's always, how does sound production change? Just fill in the blank. Over time, by region, really anything. A really cool example of using the CMU pronunciation dictionary can be found in the reference. There's a talk at Bang Bang Con, which was in New York in May, by Danielle Sucher and Darius Bacon about finding verse in text and accidental rhymes, and I recommend it. It's only 10 minutes long. And then semantics. So semantics has a special place in my heart because that's what I worked on when I was in the world of linguistics. But Python has a bunch of really cool interfaces to lexical semantics in particular. So this is just the very, very beginning of what WordNet provides. NLTK has an interface to WordNet. You can just import it. A synset, for example, is a set of synonyms that share a common meaning. But basically all of WordNet is providing a ton of different ways to define relations between sets of words, which can then allow you to do computation on them. And there are a lot of relations that you may not initially be thinking about, even though you're curious about how meanings change over time or how people use a word to have a slightly different connotation, say in applications essays versus like to schools versus cover letters. There are like endless sort of applications to endless reasons to find out why things mean what they do, how people use different meanings. And so I think like if you look at the how-to WordNet, again, this is great because there are lots of cool examples with which you can just get answers to questions right away. You don't have to understand the algorithms, you can just plug in the tools. And explaining, one second there, it'll help looking at those examples of how to use WordNet can also help explain sort of what questions have already been answered in linguistics, or like what papers have already been written, and what computation can like help if you want to push things a little further. Like what can you answer by just doing the right research, and what can you easily answer by playing around yourself. I think re-answering questions is valuable, but I also think it's worth knowing. So I said we were celebrating the intersection of like studying natural language and Python programming. Why do these jumping off points matter? Like I haven't provided a lot of detailed implementations or even like projects to do. It's just like, here's this thing, it exists, it's awesome, take a look at it. And I think that's actually a pretty good explanation. I think it's worthwhile to celebrate things that are cool, and there's a huge amount of possibility when you look at language because it touches everything we do. But more specifically, classification. Probably a lot of us have talked about it or heard about it. A lot of Python work uses classification and machine learning. This is not code, obviously, and it's not what you usually see as pseudocode, but this is sort of an explanation of how easy using these packages provided in Python can make stuff like classification. So you have a line importing a corpus. NLTK provides a lot if you have another data set, whatever. A line of code defining the data sets. So like, here's the stuff that we're looking at. One line randomly shuffling all the data. So say you have ordered data and you want to split it into a test set and a training set. You want it to be randomly shuffled. One line initializing training data and testing data, for example. And one line instantiating a classifier object, like this machine is here to get data and we'll do tests and train stuff and it'll be great. And then you can print stuff out, write other functions, do computation. This talk is not intended to give an overview of machine learning, although if you went to Sarah's talk a little bit earlier, that may have helped. But I guess what I mean by this is these Python packages can provide really easy avenues to complex things that people work on a lot. And I think that's really valuable for introductory Python and for just diving into something new, say from web programming to explaining, answering social science questions. It's valuable to be able to use these tools and understand basically what they do without being able to implement them. But it's also valuable if the goal is to implement them. Doing this first, understanding how it works, is great. This next slide is just for reference, not for looking at on the screen, but this is the actual NLTK example that I based this on. And it's doing some classifying on the names data set that's in NLTK. Another reason why this matters is because all of these things are parts of stuff like parsing and translation, which is a huge research area. Google Translate team, for example, lots of other like translation efforts and language documentation. You want to be able to find out what stuff means in other languages and translate it. And I think in showing people like what programming can do, if like, especially if they're feeling intimidated, building up from a ground level is really important. And the very simplest translation, I think it's worth pointing out, is one-to-one pattern matching. So you have a dictionary. I haven't provided string A here because I kind of ran out of space, but you have string A in one language, you have a dictionary that maps language A to language B, and then you join the words by spaces when you look up what each word in language A means in language B. So then you have a literal translation, and it's a like if you first learn a foreign language, a lot of kids will translate word by word, and maybe it doesn't make sense, but that's a step to build on. Then stats can help in more complicated pattern matching, and that's where the tools like this, there are classification tools, but there are also other packages in NLTK and in Python that are well documented that help move from a here's the literal translation of this sentence to here's something that actually probably means something close to what we want to say. And this is another area in which so now is the point when I explain why I didn't say anything about NLP in the title of my talk. I think that NLP is very closely associated with like complicated algorithms and processing and stuff like that, and that's awesome and important, but a lot of it is very heavily based on statistics and algorithms, and looking at the linguistic side of things and how people think of things on the theoretical side can help form interesting social science questions. So basically, I think that's really cool. And there are references, if you download the slides, links, stuff that I find useful. And that's it. Any questions? Do we have time for questions? Happy to answer questions. Yeah.
Does Google use NLTK at all on their search engine?
I'm not aware that they do. I doubt it. My understanding is that NLTK is used frequently as a sort of like entry point and for like researchers, but I could be wrong.
Your own research, actually.
My own research?
Yeah.
I actually don't do research on natural language processing. I started moving into computational linguistics. I now do data analysis applications at U of M. But this is a interest. Yeah.
I was once recommended to use NLTK for sentiment analysis, but it seemed too big or complex to deploy. So I kind of just gave up and wrote a really simple one. But do you have any perspective on that or advice?
I think that whether it's useful to use NLTK rather than implementing parts of it on its own depends really strongly on like the programmer's experience level, comfort level, and the space you have. Like if the space doesn't matter, I'd often use it just because I know it's nice. But in your case, I probably would have done the same thing. Like especially if you have all the data, it's a lot of room to take up, but I find it really useful as sort of a tool offline. I have not found it very useful online because of that same reason. Yeah.
What was the presentation you mentioned from May?
It is this Nantucket Hacking with Verse. It's basically about how they used a couple different methods to find accidental rhymes and create poetry. I think one of the hard things about looking at natural language is like, okay, it's really cool. What questions can I ask? And I think that's a really good example of like what questions are fun to answer that haven't really been answered yet. Any other questions? Yeah, if any of you have any experience like using some of these tools that I said I hadn't used or have used, I'd love to talk to you about it today or tomorrow.
What's the Bang Bang talking about?
It was a conference about unconference, so it's conference/unconference about the excitement in programming. So there were a bunch of 10-minute talks about things that people were excited about, and all of the submitted talks had to have an exclamation point in the title, hence Nantucket. If you go to that website, all of the talks are online, and there are real-time transcripts and videos and recordings.